This is lesson 3.7, function notation, part 2. So in part 1 video for 3.7, you learned how to compare a linear function to the parent function f of x equals x. So today we're kind of flip-flopping the lesson around, and you already did that part, and we're going to go back and talk a little bit more about what function notation is and how to use it, and also some word problems that involve function notation. And we're also going to learn in more detail how to write a domain and range for a function, specifically a function word problem, so like a real-world example of a function. All right, so functions, looks like my drawing tool is trying to warm up here, so sorry about that. I'm probably going to just need to type. Okay, so you know that an equation is y equals mx plus b for a linear equation. So the old way would be to use y, and then the new way is going to be to use f of x. So f of x is the same thing as y. So it means y, they're the same thing. When you see f of x, it doesn't mean f times x. It just means the y at whatever x is in the equation. And you've probably seen examples of like a function machine or just any examples of function. So everything works the same with y notation. The domain is the values of x for which the function is defined. I'm going to use a smaller and maybe a color. How about purple? And then the range is the value of y for which the function is defined. Well, that didn't work. Oh well. Okay, so you graph it the same way. You can make a table of values, you can find the x and y intercepts, or you can use the slope intercept where you plot the b and use the slope to get another point. All right, so f of x is pronounced f of x, and then it means f of x means the output. So remember that the y is your output and your x is your input. So output when x is the input. And then we also say the value of f, your function, at x. Okay, looking at equation, so like when x equals a certain number, where is your function located? Okay, you saw an example of that in the word problem from yesterday's Edulastic assignment from 3.5, where you had to look at the graphs when you had 4 squirrels. You had to look at the y values of the function and subtract them. Remember, it was 110 minus 90, which was $20. So that's an example of the value of f at x. And then we can use, so all of this is just things you probably know already, just different wording, different terminology. And we can use letters other than f. So you'll see g of x, you can see m of x. You can see capital letters like capital T of x, anything like that. All right, so let's do a few examples with function notation. So here, f of 3 means to evaluate f of x when x is equal to 3. So basically, you're going to take your equation, f of x equals 3x minus 15, and plug in 3. So f of 3 equals 3 times 3 minus 15. Okay, 3 times 3 is 9. Minus 15 is negative 6. Okay, so then we can conclude over here that f of 3, the function at 3, is equal to negative 6. Okay, what if we put that as a coordinate? Okay, that would be the coordinate. The x would be 3, and the y would be negative 6. Okay, so this is the coordinate x, y works the same as x comma f of x. Because y and f of x are the same thing. It's just f of x is specific for what x you're talking about. All right, so here's some examples. So f of x equals set negative 7 times x, find f of 7. So f of 7 would equal negative 7 times 7. We just plug in 7 for x, which is negative 49. Here, g of negative 2, we plug in negative 2 for x in this equation. So we have 12 times negative 2 plus 1, which is negative 24 plus 1, which is equal to negative 23. Okay, so that coordinate then would be negative 2, comma, negative 23. So when along the x-axis, when x equals negative 2, the function is way down at negative 23. That makes sense because the slope is so steep. Right, h of 0. So we would have negative 8 times 0 and minus 2. Well, negative 8 times 0 is just 0. Minus 2 would equal negative 2. So that would be the coordinate. 0 is your x, negative 2 is your output. And then last one, maybe I can try to switch up the color here if it works for me. All right, so it would be negative 3/2 times 2 plus 5. Well, negative 3/2 times 2, let me show you. So negative, oh, this isn't going to work. Come on, use the pen tool. I guess my pen tool is not wanting to work for me. Okay, my smart slate has woken up, so that's good. So this is negative 3/2 times 2 over 1. Okay, but for this here, the 2's will cancel. You'll just have negative 3 plus 5 equals negative 2. Okay, so P of 2 is equal to negative 2. All right, and then we're going to go straight to these problems. So here we've got a word problem. It says the average price of a movie ticket in the US from 1980 to 2000 can be modeled by the function f of x equals 0.10 x plus 2.75, where x is the number of years since 1980. All right, so it says to graph the function and identify the domain and range. So first of all, what you need to know is that 1980 to 2000, and x is the number of years since 1980. So whenever you see a problem like this, and I'm hoping, all right, this is still not really working for me here. All right, whenever you see a problem like this where x is the number of years since 1980, that means 1980 represents x equals 0, your starting point. Therefore, x 2000 would be 20 years later, but 20 years after 1980 would correspond to the point x equals 20. Right, so you're starting at 0 and you're going to 20. So let's go ahead and, for you, luckily for you, your graphs will always be given to you in Edulastic, but later on we're going to learn how to set up a graph. So let's go ahead and make an x and y axis, and we're just going to be working with the first quadrant because you can't have negative price and you can't have negative time. So I'm going to make a big xy axis, and we know that x goes from 0 to 20. So I don't know if I have 20 ticks on here. Maybe I do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20. Okay, I guess I do. So when you label, you can just do maybe label every 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So this is the number of years. All right, and then how about for the y? Well, for the y, what's going on here is that, so you're starting at 2.75. So what does that mean? Well, in 1980, if your y-intercept is 2.75, that means in 1980, the price of a movie ticket was $2.75. Okay, so this means your y-intercept is 2.75. So that's good to know what these things mean in context. So in this, the y-intercept means the price of a movie ticket, and maybe we should write that down here. So price of a movie ticket, I'm just going to say a ticket in 1980. Okay, and then the slope, so that's what the B means. The slope means that the average price of a movie ticket will increase by 10 cents per year. So price increases 10 cents per year, or $0.1 per year. Okay, so that's what those things mean. So here's how we're going to do this. You're going to do two different points. You're going to graph your y-intercept, and then you're going to graph when x equals 20. So our y-intercept is 2.75. So that's the first point that we're going to graph, but we're not going to graph it quite yet. Let's just figure this out here. 2.75. And then what's going to be the price after 20 years? Because you only need 2 points to make a line. So that's the other point we're going to get. Well, if you plug in 20, so this is going to be the end of our graph. Let's plug in 20 into our function. So here, what's f of 20? What's the price in 2000? Well, so let's go ahead and plug it in. So 0.10 times 20 plus 2.75. Well, oops, this should be close parentheses plus 2.75. If you plug that into your calculator, you're going to get $4.75. Okay, so the other coordinate we're going to plot then would be 20. Make sure you're writing all this down. 20 and then $4.75. Okay, so for the graph then, what we can do then is we need to go from 0 to at least $5 in order to capture both of these points. And then instead of going up in ones, like 1, 2, 3, 4, 5, since we have like 2.75 and 4.75, we can go up in increments of 50 cents. So maybe every other will be $1. So 1, 2, 3, 4, and 5. And once again, in Edulastic, this will be given to you, but it's good to know where these numbers come from and why we set up our graph, why the graph is set up like that. Okay, there's always a reason why a graph is set up the way. And maybe when we all come back to school, I'll have you learn how to do this on your own. All right, so let's go ahead and then plot the points. So the first point, the y-intercept is 2.75, would be right there. And the other one, after 20 years, would be 4.75. And then, since we're only talking about 0 to 20, we're just going to use a line segment. Okay, we're not going to use a line because that would mean that it goes past 20 and before 0, but it doesn't. Okay, and then if you label your y-axis, this would mean a price in dollars. All right, so then we also have to write the domain and the range. So here's how you write the domain. So the domain is all of the x's, and as you can see here, it goes from 0 to 20. So we'll say 0, and I don't know if I have a less than or equal button on this, so I'm just going to say less than or equal to 20. Oh, sorry, we're talking about x, and then less than or equal to 20. Okay, so 0, less than or equal to x, less than or equal to 20. And the range will be whatever you had for your y. So it'd go 2.75 to 4.75. So 2.75 less than or equal to f of x, less than or equal to 4.75. Okay, that's how you would write the domain and range for those. Okay, and then find the value of x so that f of x equals 455. Explain what the solution means. Okay, so this is the last thing we'll do here. And well, if you plug in 4.55 to the equation, so f of 4.55 equals 0.1 times 4.55, and then plus, what were we adding to it? 275, yeah, that's right. Plus 275. Well, you might be able to do this in your head. 0.1 just moves the decimal place over. So, actually, wait a minute. I apologize, you guys. This is not how you do it. I don't know what I'm thinking. All right. 4.55 is your f of x, and you're finding x. So you're given the price, and you're trying to find the year at which that price occurred. So for our function, we're going to plug in 4.55 for f of x and solve for x by subtracting 2.75 over. So minus the 2.75. Okay, so this would give us 1.8, 0.1x, and then divide that by the 0.1, and then that would give us 18. So that means, because it did say to explain what it means, after 18 years, so in 1998, the price of a movie ticket was $4.55. Right, so that concludes this lesson. We will do more examples tomorrow in class. Hope you have a great day.